Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Kami dari kumpulan 5 Seksyen 4 BNP 20203 Mechanic of Materials akan membentangkan tentang progres projek kami. Sebelum itu, izinkan saya kenalkan diri dan juga rakan-rakan saya yang lain. Nama saya Wan ADLIN AMANI binti Wan IKFAL YAMIN. Bersama dengan saya AHMED IRFAN bin Nur AZMEAN, HILMAN HARIZ bin Muhammad RIZZUAN, ARVEEN anak lelaki PARAMASIVAM dan akhir sekali NURFAATIHAH AQILAH binti ABDUL HADI. Di dalam video ini, kami akan bentangkan tentang bridge design and drawing, seterusnya Gantt chart, kemudian work breakdown structure dan akhir sekali ialah minute
Basically,
meeting.
what are the definition of trusses? Trusses is a structural framework made of straight members connected at joints, and it carries loads through tension and compression. Trusses are mostly lightweight yet strong for a long span structure, and trusses are usually used for structural work that require a long span. Last but not least, trusses are commonly used in bridge, roof, towers and also industrial structures. There are many types of trusses in this modern era. For example, we have Pratt Truss, we have Howard Truss, we have Warren Truss, we have K Truss, and there's a lot type of trusses in this industry. Moving on to the next, which is project design concept. So for our project, we have decided to use Pratt Truss design as our type of trusses. Why do we choose Pratt Truss? Firstly, the structure is made up vertical members, diagonal members and top and bottom chords, where there are 3 ways for the trusses to spread the load, which is through the vertical members itself, the diagonal members and also top and bottom chords. Moving on, vertical members mainly carry compression forces, while diagonal members are designed to work in tension or slope. Lastly, top and bottom chords provide overall stability to the trusses. We're heading to drawing, plan, modeling. So as we can see, this is one of our greatest innovation, one of our greatest drawing that we have ever made, which is the Pratt Truss design. We use AutoCAD software to do the whole design, including the isometric view. So what are the truss design parameters? Firstly, the material used are only balsa wood stick with 5mm thickness, not more than 5mm or not less than 5mm thickness. Next, we use super glue, but only for 3 seconds, not more than 3 seconds, not a hot glue gun, only a super glue. For example, elephant glue, gam gajah. Next, the maximum model span are 600mm, which is the total length for our modeling, which a 6 meter 1 to 10 scale. So for each members, the length are 100mm each, and the bridge width and height are 100mm times 100mm. The total joints for this modeling are 12 joints. So I'm gonna pass to my next member.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hussein HARIZ bin Muhammad RIZZUAN. My matrix number is CN240457. So today I'll be explaining about our design load support and our design characteristic. So for our design load supported, basically our bridge is designed to support both concentrated and distributed loads. It performs based on the AHMED span point load, where the forces are transferred evenly through the truss members to the support. The structures will also remain stable under repeated loading. And for the load, our 6300mm balsa wood bridge, our estimated was 40 to 70 kg for a standard build and 60 to 100 kg for a reinforced build, and it is showing that the reinforcement significantly increased the strength of the structure. And next, for the design characteristic, for the design and evaluation, the bridge uses tension diagonals to maximize balsa wood strength, while short compression vertical members to reduce the risk of debuckling. The top and bottom chords resist bending, and the symmetrical design ensures balanced load distribution. The structure is also statically determinate, making it easy to analyze. The advantage of this design includes simple construction, good performance under mid-span loading, efficient material use, and low buckling risk. However, the disadvantage are lower strength compared to complex trusses, lower redundancy, and slightly higher deflection at the maximum load. Overall, this design is suitable for balsa wood construction, and it makes it easier to assemble due to fewer members, and also ideal for mid-span load testing, which meets the objective of our project.
Greetings to Dr. Nurul Hidayah. My name is Jia Ariana Laki Paramasivam. My matrix number is CN240421 and I'm here to present the project Gantt chart. So these projects begin on week 5 where our team began by choosing the Pratt Truss bridge design as our project topic. We also formed our group, assigned initial roles and reviewed the project requirements given by our lecturer. Following up, this progress was 100% complete, and following up on week 6, it was an initial research and concept study where we carry out preliminary research on different types of trusses such as Pratt, Howe, Warren and K-Truss. We compared their advantages and weaknesses before confirming Pratt Truss as the most suitable design based on strength, simplicity and stability, and for week 6, it was 100% progress. On week 7, we initiated sketching and early design planning where we focused on producing early hand sketches of the bridge. We identified critical members such as verticals, diagonals and chords and planned the dimensions according to the 600 mm model scale. This helped prepare us for transferring the sketches into AutoCAD software. So for week 7, it was 100% progress. Pulling up for week 8, it was more to a research, AutoCAD drawing and material planning. So for week 8, we researched truss bridge design in depth and transferred our sketch drawing into AutoCAD. We also discussed the required materials for the model such as 5 mm balsa wood and superglue and began collecting funds for purchasing the materials. For week 8, it was 100% progress. Following up for week 9, we're finalizing the design drawings. Our team evaluated the progress of the project and finalized the complete AutoCAD drawings of the bridge. This ensured that all dimension and joint placement were accurate before construction. So for week 9, it was a 95% progress. Following up for week 10, we had a meeting and project coordination. Involved a formal project meeting where we documented decision and coordinated tasks for the construction phase. This helped ensure everyone understood their roles for the upcoming weeks. So for week 10 minute meetings, it was a 33% progress. Following up for week 11, where material purchase and construction phase begins. So we assume that in week 11, we purchased the materials that we had planned earlier. We then began cutting and assembling the balsa wood members according to the finalized dimensions. This progress will be updated in the following weeks. For week 12, we have predicted and assumed that during week 12, we would continue the construction phase focusing on assembling joints, reinforcing diagonal members, and ensuring the truss structure was stable and aligned properly. On week 13, the load test preparation will be conducted, where week 13 was dedicated to preparing the bridge model for load testing. We will check the structural alignment, apply small reinforcements, and ensure the bridge was ready for concentrated and distributed load evaluation. And finally, for week 14, the final load testing and report completion. In week 14, we would carry out the load testing to analyze the bridge's performance under different load types. We will record the results, document the outcomes, and complete the final project and the project report and the presentation. So this is the overall track progress of the Gantt chart of our project. Thank you so much.
Nama saya NURFAATIHah AQILAH binti ABDUL, nombor matrix CN0146 akan meneruskan pembentangan ini. Slide ini menunjukkan work breakdown structure WBS untuk project Truss Bridge. WBS digunakan untuk memecahkan projek pada beberapa bahagian kecil supaya senang dipantau dan dirancang. Terdapat 4 fasa utama dalam WBS ini. Pertama, project initiation dan planning iaitu pembentukan kumpulan, sesi briefing dan kerja-kerja planning serta administration. Kedua, design dan preliminary work yang melibatkan design selection, menyediakan design drawing, pembelian material dan design submission. Ketiga, physical model phase iaitu pembinaan physical model dan ujian model untuk menilai prestasi struktur. Dan terakhir, documentation dan submission iaitu penulisan report, menyediakan report, status dan final submission. Secara keseluruhan, WBS membantu projek berjalan lebih teratur, memudahkan pembagian tugas dan setiap fasa disiapkan mengikut masa. Seterusnya, saya serahkan kepada ahli.
Akhir sekali, saya akan bentangkan tentang minute meeting pada minggu ke-8 dan 9. Untuk minggu ke-8, kami membuat carian berkaitan reka bentuk bridge truss dan seterusnya memilih reka bentuk yang sesuai untuk projek kami. Seterusnya, kami pindahkan lakaran lukisan ke dalam software AutoCAD. Kemudian, kami berbincang tentang pemilihan bahan projek seperti membuat carian di platform online dan mengumpul dana untuk bahan projek. Seterusnya, untuk minggu ke-9, kami bincangkan tentang progres projek kami seperti mengumpulkan semua bahan-bahan projek yang telah dibeli. Akhir sekali, kami finaliskan lukisan reka bentuk projek kami. Itu sahaja daripada kami. Sekian, terima kasih.